ଯିବା କଥା। Devalina, good morning. Good morning to all the participants. Am I audible?
Yes.
Good morning, sir. Good morning, ma'am.
Good morning, sir. Good morning, ma'am.
Good morning, everyone.
So Devalina, just continue. I'll go for a meeting for 10 to 15 minutes. Okay, I'll come back then.
Okay, sir.
Okay. Let all the students join. I'm disabled the waiting room, so anybody can join now. And I think I have already made you this co-host, so you can share the slide. I think we can start 10 o'clock, so we don't have the time. So we can start and let all join later. Okay.
Yes, sir.
So if any problem, they will just ping me. Fine. So I'm
Yes.
there in a meeting. Just ping me in WhatsApp. Fine. Just check whether slide is you are able to share the slide or not.
Yes.
Post means you can share.
Yes, sir. Is it? Oh,
Okay, you can continue. Okay.
okay, sir. So in today's session, we are going to introduce some of the concepts related to data science. We'll also tell you what is machine learning, but it will be only a brief overview of these concepts. And we are going to provide you with some suggested mini projects, and you can work on these projects. We are also going to share the resources from where you can learn. Apart from that, we are going to see some of the libraries in Python. So today we are going to learn how powerful libraries are available in Python and how you can use them to work on your own data science and machine learning projects. So I'll also give you a demo today on one of the problem statements that we have come up with. So it is one of the popular disease prediction problem, which is a classification problem in Python. So we will see that as well. So a lot of interesting things are going to be discussed in today's session. So try to attend both. And now we will discuss some of your data science concepts. So good morning and welcome to day 3 And I congratulate you all for mastering all the basics of Python. And if you are not yet really confident on your newfound programming skills, just keep practicing. Just write your own Python scripts, experiment with it. And like that, you will find yourself getting familiar with all these concepts. So the agenda of day 3 in total is to provide you with an introduction to data science. And these 3 popular libraries used for processing data, for pre-processing all your data sets, especially when we are working on data analysis and data science. NumPy and Pandas are very popularly used. Matplotlib is used for the purpose of data visualization, like for creating plots like bar graphs, bar charts, plots, scatter plots, histograms. So for that, we have Matplotlib. So let's get started. We live in a data-driven society. So when you look around, whatever applications that you use or whatever devices that you are communicating with on a day-to-day basis, all of which are now data-driven. Suppose I ask you that, do you have a social media account? The answer to that would obviously be yes. Most of us nowadays, we are on social media, any social media platform. Like we have Facebook, we have Instagram, we have Twitter. WhatsApp is also a messaging app. Still, it's also kind of storing your data somewhere. So in this data-driven society, it is very important to know how we are going to make use of this data to get some insights from this data. So data is present everywhere. It is present in a raw form. You have to convert this raw data into some valuable information. So that is what your data science is all about. If any one of you might be using smartwatches. So smartwatches, they are storing your biometrics, then online shopping platforms like Amazon, like Flipkart. So on these platforms, you have your product preferences, your reviews are there. So those also form as the data, as part of the data, and it is used by the companies to arrive at some insights related to their marketing strategies, etc. So what is data? What do we mean when we say the word data? Data refers to the individual facts. These can also be your statistics or some specific item of information. And these are usually numeric in nature. However, we also have something called as unstructured data, which is present in the form of images or videos and audio, or even just text on any platform. So these comprise of the data that is available at your disposal. We all must have heard this term big data. So what is it all about? It defines huge amounts of data. It can range into petabytes of data or even higher. So those huge collections of data is referred to as big data. The availability of such huge amounts of data has encouraged this field of data science. If we did not have data, then what would be processed? But now that we have so many resources available to access data, so many portals from where we can collect data. So now we can convert all this data into some relevant information. One more thing that assists this field of data science is the availability of high computational resources. So like I gave you a demonstration on Google Colab, from there you can access high computing resources such as GPUs and TPUs. Those make your data processing even faster. So we can process huge amounts of data in a very less time. Now we formally introduce you to data science. Essentially, it means that we want to find some useful insights from data. It is a multidisciplinary approach and we are trying to extract some actionable insights. The volumes of data that is collected or created, it goes on increasing each and every day. So even in a fraction of second, someone is contributing to the data available on some online platform. So this ever increasing volume of data, the data source is always available and is always increasing. So this motivates us to work in the area of data science. Other than that, we have modern tools and techniques available. Using those, we can have our own data science projects. And using the procedure, using the data science methodology, we can derive some meaningful information from this data. And this information can help us to make some business decisions. So this is mostly used by companies to make business decisions. However, if someone is working in the area of, suppose, genetics, and there are huge amounts of data on DNA or related to other areas of biology or anything like all related to your genetics itself. So when using these tools, we can even apply to our own domain, our own problem statement that we want to solve. So it helps us to automate the processes. If we have huge amounts of genetic data, we can use the data science concepts to even automate those particular processes and use even advanced algorithms to find some meaningful information out of it. So what is data science all about? We said that it is interdisciplinary. So these are some of the disciplines from which data science is composed of. So the first one is mathematics. So a lot of mathematical concepts are included in your data science. Then we have statistics, advanced analytics. We also have programming. So whatever we are going to do, whatever scripts we are going to write to extract some data, it is going to be done in your Python programming in accordance with this workshop. However, there are other programming languages like R is also there, but Python is the most popular and most preferred language for your data science projects. We also have artificial intelligence. So if you want to make predictions from the data that we have, for that purpose, we use artificial intelligence. Artificial intelligence like machine learning is there. So over there, we use machine learning to derive some predictions from our data. Something which is very important is having some domain knowledge. So whichever problem that you identify, whichever problem that you want to solve using your data science approach, you should have some domain knowledge. So when I suggested that you can solve some genetics related problem using data science, we also have the underlying meaning that we expect you to have some domain knowledge related to the genetics. If we are working with text data and we want to derive some useful insights from the data, we also want to create some model, predictive model using the text data. So in that case, we want you to have some knowledge regarding text mining or text analytics or like natural language processing. So that comprises your domain knowledge. Whichever domain you want to work on, you should have some basic fundamental knowledge regarding that domain. We also should have some researching abilities because a lot of data science projects will involve some research. And lastly, storytelling. It is also, it is not really highlighted, but you should be able to tell a story using your data science project, like what your data comprises, how did you collect your data, what was your problem statement, and things like that. So the presentation ability, the storytelling ability, the ability to convey your meaning to someone else, that also comes in your data science area. Okay, so now we see how this interdisciplinary field of data science is composed of. We have computer science and IT, we have math and statistics, Plus we have some domain knowledge, or if someone is working in the industry, for them the business knowledge will be relevant. And for data science, three things are very important. Number one is your traditional research. You should, and by research, we don't mean that you should have all published papers or anything, but we just should have the ability to research, which means that we should have that enthusiasm to try again and again. So that is what research is about. We have to experiment, we have to learn new concepts and just repeat it again and again. We have to some resources. So to gain domain knowledge, obviously you have to study a lot. And over here we have software development, which includes your programming skills, and we have machine learning. The very first step that you should be aware of is that the problem definition is very important for your data science projects. So before tackling this data collection and data analysis part, a data scientist will determine the problem by asking the right questions and gaining some understanding on that. Asking the right question, identifying the right problem is extremely important in any data science project. So you ask yourself, what is the problem that you are trying to solve? And how can you use data to solve this problem? What data do you need for this purpose? So like I said, we are going to implement a diabetes prediction problem. So now I know that what is the problem that I am trying to solve. I want to have a disease prediction problem. And here I have the disease that I have selected is diabetes. The next step is how can you use data to solve this problem? So if patient records, if some data is available, it will help me to find some pattern within the data to identify what are the factors due to which a person gets diabetes. So I can answer the second question. And number three, what data do you need for this purpose? So how should my data be? So for my purpose, I will prefer to have some numeric data. I want it to be present in a tabular format so that I can process it and perform my computations. So like that, we define the problem. Next step, now we understand what the data science pipeline is all about. So we have to focus now on our data science life cycle. So it is composed of 6 distinct stages. The first stage is data acquisition. So in data acquisition, we are gathering the data. So this data can be structured raw data, or it can also be unstructured data. So when we say structured data, we mean data which has been organized in a tabular format, suppose like in an Excel sheet. And unstructured data includes your images, text, audio, video, things like that. The next step is data preparation. So it will involve your data pre-processing part, like taking the raw data and putting it in a suitable form that we want to use in our project. The next step involves data analysis, where we are going to analyze, perform certain analysis steps, such as we want to examine some patterns or the range of values which are contained for a particular feature. And data analysis is important to get an overview of what is exactly contained within your data set, the data collected data. So what does it have? Some statistical things like we want to find the median of values, or we want to see we want to normalize the values contained. So all those steps are happening within your data analysis. Data modeling, in modeling, we can have your machine learning models as well, or we can have statistical models using which we want to extract some useful insights from your data. Data visualization is the process using which we create those bar graphs or the plots, which gives us a visual perspective to the data. So it might get boring to just see numbers. We want to see some visualization. We want to have an overview of the data, how the variables are getting related, what kind of relationship these variables have with one another. So all of that is contained within your data visualization. And finally, after following all these steps, we deploy the model. So stage 6, the final stage, we can also say that here's where our storytelling comes into play. So after going through all these stages, we now able to conclude our science project, and we can tell the results which we obtain from this entire process. And so when pipeline, we are going to look closely into data analysis and data visualization. So so working with data to get useful information is what is called as data analysis. So it is the practice of working with data to gather useful information, which can be used to make some informed decisions. And in data analysis, it involves the cleaning, changing, processing of raw data, and then some relevant information is also extracted to help answer some important questions. So before we create the final model, we want to answer some questions related to the data that we have. So that process is included in your data analysis part. In data visualization, we represent the data using visual elements. So we have charts, plots, infographics, or even animations. So we want to represent our data through the use of common graphics. These visual displays enable us to communicate this complex data relationships that we have. So we are not going to have simple X and Y relation. We will have lots and lots of features in your data. So we want to see what is the relationship between all these variables. So for that, we can use data visualization techniques. And it is also easy to understand. So if you want to explain your insights to someone belonging to non-CS background, non-programming, or someone who is in a business field, so you can express that your results in the form of visualization. Next, we shall come to the Python libraries. The first library that we are going to see is called NumPy. It also stands for numerical Python. It is a library which helps us to work with multi-dimensional array objects. And a lot of methods are also available in NumPy for processing these arrays. It is a fundamental package for scientific computing available in Python. And the dimensional array objects using NumPy, these are very powerful because they are faster and we can save a lot of resources. In data science, when we're working with data, we want to have a speed of execution to a good level. For data structures. So one such data structure is your n-dimensional array object. The next library that we are going to look at, it is called Pandas. So it is also a software library written for Python programming language, and it is mainly used for your data manipulation and data analysis. There are many data structures and operations that are available within your Pandas. So some of this is called series and data. We will discuss everything. We will also create our own data frame. And this Pandas, it has a lot of functions that help you to analyze your data, to clean it, to explore the data, as well as to manipulate the data. And
Debolina, I think your voice is not clear.
Sir, maybe network issue.
Yes, yes. No, we are not able to. We are not audible, Debolina. Check your network. I think some issues are there. Nobody is able to listen you. Not audible. I think you just go out again, log in, I think, something like that. Log out and log in again. Objectives is to do the mini projects. So whatever things we learn here in this 3 days, now we have to implement all these things in a project. The project may be very small, but we have to implement these things. Okay. So in the second session, we have around 3 to 4 projects are there, or 5 projects are there. But you can also give your problem statement so that we can formulate that one, how we are going to proceed, plan for that one. And second thing is, ma'am also will show one project, how we are going to retrieve the data, from where you will get the data set, what to implement, how to decide, what will be your objective, what will be abstract, how to write the problem statement. Everything will be shown by ma'am in the second session. Okay, so that is the main objective, to do a good project. Python, anybody can, anywhere, from anywhere you can learn. But how to implement those concepts in your programming, in your project, that is important. So let me call to Javelina ma'am. What happened? So let us wait. Okay. Some network issues are there. So ma'am will join very soon.
Hello, am I audible now?
Yes, ma'am.
Yes, ma'am.
You can share the screen. You are audible now.
So I was discussing Python libraries previously. And so we saw that we have NumPy, which is one of the fundamental packages for scientific computing. It offers multi-dimensional array objects, and it also has collection of methods that we can use to process these array objects. And in data science, the speed of resources is very important. So whatever ways we use, whatever storage, the collection the collection types that we use for storing the data. So that should have faster processing. So for this purpose, we use NumPy. Next, we saw that we have pandas. It is used for data manipulation and analysis. It also has some data structures that we will shortly see. So these data structures are your data frames and series objects. So they are used to manipulate numerical tables and data sets. And it also has functions for analyzing or cleaning the data, for exploring what is contained within your data, and for manipulating the data. And finally, we are going to discuss one more library, which is Matplotlib. It is used for your visualizations. So we can create different graphs and plots for data visualization. And here Matplotlib contains several plots like line, bar, scatter, histogram, etc. Now we move on to the implementation. So all of you get ready with your Google Colab notebooks. The first library that we will work with is NumPy. So earlier we were only using classes, we were working with data types and different constructs, like we had if-else conditional statements, we had for loops. We now know how we can define our own functions, and we also have some idea on how we are going to create classes in Python. Libraries are you create these libraries using all these fundamental tools, but it is like on a very large scale. So it has immense number of functionalities available. You can import the NumPy package. You can load the NumPy package in your Python environment using the keyword import. So we write import NumPy as NP. As is a keyword in Python, which helps us to create an alternative name for this particular library. So instead of writing NumPy everywhere, we come up with a short form, which is NP. So load it and check what is the version available in your Colab notebooks. Or if you're working on a local installation, in case someone is, then you can also check over there. Okay. Next, after we have imported the library, we are going to create a one-dimensional array. So for that, we write np.array, and it is a function. And within that, we provide the list of numbers that we want to load as a one-dimensional NumPy array. So you may ask that if lists are already available, then why do we need NumPy arrays? So if we try to use lists for loading data. In that case, the processing tends to get slower. Lists do not have the optimization available within the environment. So specifically for working with huge amounts of data, NumPy is the to-go solution. So that is why instead of having lists for data science and data analysis purposes, we use NumPy arrays. So have you all created your first NumPy array?
Ma'am, mine is underlining the NumPy as it doesn't recognize the NumPy.
Are you working on Colab or other environment, other IDE?
I'm working on VS Code.
On local?
Yes, ma'am.
So for that, you have to add one statement, preferably in your command line, you can do that. It is pip install NumPy. So when you run this, or if you are using Anaconda, are you using?
No, just VS Code.
Just Python?
Yeah, Python from the VS Code.
Okay. So for Python, when you have the command line, over there you have to install your NumPy package.
Internet, it will better just do it now in Colab. Okay, later we can see for that.
So
Okay.
for
The
now,
last of installation is required. Installation.
so Colab gives all of these libraries pre-installed in the environment. So you don't have to install these libraries separately. It is already installed, already available to use. This is one of the reasons that we chose Google Colab, because we can skip the installation and directly focus on the functionalities. So if you want to install, you just have to follow this command, pip install, and the library name, it will install your libraries in Python. Another command is conda install and the library name. So if you are working on Anaconda prompt, over there you can use it. For now, it will be better if you just come onto the Google Colab notebooks so that we can just code along. I've got 3 responses till now. Anyone else? Have you been able to load NumPy and create your own array? Okay. We'll also see different types of arrays. So just like in lists, we can have collection of different data or data types. Over here as well, we can have a string type of your NumPy array. So here we have np.array and we have apple, banana, cherry, and we want to print it out. So it looks like a list, but if you want to check the type, it tells you that it is in fact a n-dimensional array. So ND array, it stands for n-dimensional array. So first we have this one-dimensional array that we are working on. It looks like a simple list. Okay, moving on, we can also use this function array to create arrays having a specific data type. So over here we have our integer type data, and we want to print, we want to store this not as an integer, but as a string. So we can do this using D type. So it is a parameter within the array function, which allows us to specify the data type. So this is also one of the ways in which you can create your NumPy arrays. In case you are seeing this B1 coming over here, so it's actually one of the characters, like when we are changing an integer to a string using this way of specifying the types, it appears like this. So we will show you like how you can actually have the conversion properly. So this is just a functionality which is available, which is why I mentioned it over here. This is the proper way of creating your arrays. So first we define the array and then we can specify its type. So this is the most preferred way. This is the coding style which I follow in my projects. I define the array the way it is, and then if at any point of time I need to change its type, the data type, then I use the as type function to perform that computation. Over here, we have first defined our NumPy array containing floating point types. So 1.1, 2.1, 3.1. And now we want to store it as an integer. So for that purpose, we have the NumPy array object. So yesterday we saw that we have objects created in Python and using the dot operator over here. So array dot and the function that we want to invoke. So over here, we want to call the as type function. And we want to change the data type, the existing data type of ARR into integer. So every value which is contained within this array will be changed to an integer. Okay, so we can see that the array got converted to an integer type. We can also check the data type of the array. So for that, we have new ARR dot D type. So this is the attribute for your new ARR, the NumPy array object that we have over here. And we can access the attribute value in this manner. So dot D type gives us the data type of this newly created array. Please try this code. I'm also posting it in your chat box. Please try run. If anything that you want to ask. Okay. We can also change into other types. So we can change an integer to a Boolean type. But always remember that a Boolean data type, it recognizes all other numbers as true except 0. Okay. So when we have 1, it also stands for true. When we have 3, it is also true. But when we have 0, it comes as false. So only 0 only 0 will stand for false, and all other numbers it gives the true value. So now we have again an integer array 1, 0, 3, and we want to convert it into Boolean. We use the same function over here as type, and we specify the bool data type. Okay. So see that even with negative numbers, Boolean recognizes it as a value true. So it's only 0 which stands for false. Other than 0, every other number is true in a Boolean type. So try to convert the type of your NumPy array to a Boolean. Okay. Following this, we are going to now see how to create 2D arrays. So we are when we will be processing data. Mostly we will be working with 2D array objects. So even in other kinds of problem statements, we have n-dimensional arrays. Those are actually used. Suppose we can even have 3-dimensional, 4-dimensional, 5-dimensional arrays. So when as and when you progress in this area, like data science, and you try to build your own projects or experiment simply by even loading complex data on your system. So at that point, you will see that as the complexity of data increases, you will also have to increase the complexity of your NumPy arrays. So here we are working with very simple arrays. These are just 1-dimensional. We'll see till 2 or 3-dimensional today. But you can have extremely complex data types, data arrangements, which you can load in your NumPy. So, which is one of the reasons why it is so popular for scientific computing. Next, we shall see how to create a 2D object, 2D array object. You define your 2D array in this manner. So I'll just work it out on a separate cell. Right, my 2D array.
How about you?
Any question?
No, Devulan, you can continue.
Okay. So in my 2D array, we have np.array. First, we create the outer body for the list. So it is like a list within a list. So in that manner, we have first created the overall 1D array. Within that, we will have some rows of data. The first row that will be contained. So think of it like a matrix, okay? So if we have a matrix, it will contain rows and columns of data. Similarly, we create this particular 2D array object. We first define the first row, 1, 2, 3. If we want to define another row, we will separate it using a comma and hit enter. So for, you can directly write over here as well, but for better readability, you can just hit enter. You will come on to the next line where you can write the next part of your array. So now we can have 4, 5, 6. If you want yet another row in your matrix, you can have 7, 8, 9. Okay. So now we have created a 2D array, which actually looks like a matrix. It will work like a matrix of data. And just hit enter. And we have created the array. How does it look like? Let's check. So this is how it appears within your NumPy. Try to create your 2D array. You can also write it in a single line. So no issues. It's just your preference, whichever way you like to code it. We can also write it like this. And we still have the implementation, the appearance of the array in this. Dula, I just saw the error that you have. It's because you have a double comma after 7. It's a syntax error. So just remove 1 and it will fix your code. Okay. So has everyone been able to create your 2-dimensional array?
Ma'am, must the output have the double square brackets at the end?
The use of these square brackets.
Yes, it has. There are 2 of them.
So when we are creating the array, it's just a syntax which is followed. So we can create a NumPy array using a list of lists. This is one of the expressions that we can use from other data types as well. So we have lists in Python, we have dictionaries, we have your tuples. So one of the data types, just we can try, if you have this query, then we can try creating, sorry. These square brackets, they represent the list. Okay, so how about a tuple? Let's see. See, so np.array is a function, and to this function you are passing a sequence object. So we saw that collections of data items can be stored in some sequences like your lists and your tuples. So what we can do is we can create our own list of numbers, and when we pass it to the NumPy array, this function array present in your NumPy. So when we invoke that function, we can convert it into a NumPy array. So this is not a 2D array. This will be a 1D array over here. Is it clear? These square brackets are your list. So we have 3 lists over here. Within one single list, we have 3 lists. The first list contains the first row of data. Second list contains the second row of data. And third list contains the third row of data. If you're getting a name error, it means that you have not imported the library. So use import numpy as np. And after that, when you execute the code, it will be fine. Also, that np is an alias. We are using a short form to represent the name numpy. You can also use numpy.array. If you have not used an alias, you can simply write import numpy, and then you can call numpy.array. So you can write it like that as well, depending upon your own preference, whichever way you want to code. There is no hard and fast rule in which way you should code in Python. It's just one person to another. We have some preferences after working for a while, and then we start following those conventions. Okay, so is this part clear? Is it okay now? I think Bertrand, you asked the question.
Yes, ma'am, it's okay. That's good.
Okay. Others?
Yes, ma'am.
We import NumPy as Python doesn't have arrays. No, Python has arrays, but it does not have a specific data type for arrays. We are using lists. We use lists to work with collection of integers or floats. So collection of items are there, which we can work out using lists. So momentarily, we were using lists in Python as an array. But when we are working with huge amounts of data, that's when your list processing speed kind of gives you a challenge in data science projects. So specifically designed for data science, we have your NumPy arrays. To Roshan, I hope that answers your query. Python does not have explicitly defined arrays. We don't have arrays in Python, but we use lists to simulate the arrays. Lists are essentially a collection of data items. And using lists, we can just have an array-like object. But over here, when we have NumPy arrays, so yes, this is the actual working of an array. We will see indexing and everything. It works similar to the arrays that you have in other programming languages. Okay. Vibhudatta, which part do you want the explanation for? We'll solve a lot of examples. So if something is still seeming new to you, something is seeming strange, like how is it working? When we work out a lot of examples, things will get more clear. So we can see there is a 2D array object. It has 2 rows, first row and second row over here. We can check the type of your array object. We can print the array dimensions, array.ndim. It gives us the array dimensions. We can print the shape of the array. Then the total number of elements of the array, as well as the all the type of elements contained within the array. So let's execute this. So we have our first two-dimensional array. Then we print the type of array object. So it gives us the numpy.nd array. The array belongs to the numpy class, the numpy type. Next, we print the array dimensions. So when we have already created our array object, now we can access its attributes. Array.enddim, it gives us the dimensions of array, the one that we just created. So over here, number of dimensions is 2, which implies that we have a two-dimensional array. Had it been a one-dimensional array, the number of dimensions would have been 1. Next, we can also have the shape of the array. So all of this is contained within the attributes of your NumPy array that you create, this object that you created. So these are the attributes of the object. So now we access arr.shape, shape of the array. So we can check that it comes as 2, 3, which means that it has 2 rows and 3 columns. So over here, you can see we have 2 rows and we have 3 columns, first, second, and third. We can also see the total number of elements contained within the array. For that, we have the attribute size. So we call arr.size. Using that, we can access the total number of elements within the array. So over here, the size of the array tells us that we have 6 elements. And the last one, we print the type of elements within the array, the data type of elements. Overall, this array belongs to the NumPy type. However, what is the data type of the objects contained within the array? For that, we have arr.dtype, and we have the output over here as integer. Integer has some varieties, so accordingly, you have int 64 over here. Okay. One of the participants was asking me to explain some part. Vibhu Datta, are you present? What was your query? Can you just type in? Because I'm not able to understand which part do you want further explanation for. Okay. For others, is there anything that you want for a more explanation? These are just the attributes, okay? So we are just accessing the size, the shape, the end dimension, the data type. Okay, okay, fine, it's clear then. Moving on, we'll see the dimensions of different and NumPy arrays. We also have something called as 0 dimension. So when we define np.array and we just have one single element, so in that case, we have a 0 dimension. So that is by convention, the built-in way in which this array has been constructed. Accordingly, we say that when we have just one single element, we say it's a 0 dimension. Now we have an entire sequence of objects, the sequence of integer items. Now we have our one-dimensional array. So B is one-dimensional. C over here is now two-dimensional. So we have 2 rows of data. Further, you can also have 3-dimensional array objects in NumPy. For that, first you define one array. Okay. I know things can seem a bit complex, so just follow me. So first we have one array over here, one full matrix, and the next we have another one. So this is how we define three-dimensional arrays. The complexity will only go on increasing now forward. So up till the two-dimensional array, if it is clear, then no issues. So your three-dimensional array is optional. For basic Python, we don't need it, right? So it can seem a bit complex. So only with after working with some different types of data, you'll be able to understand how it works, how it is arranged within the memory. So we'll discuss it later on. But till this, zero-dimensional, one-dimensional, two-dimensional, this should be clear to all. Okay. So I suppose that up till this part, zero-dimensional, one-dimensional, two-dimensional, this is well understood by all of you. Okay, so if anyone is facing an error like NumPy NP is not defined, in that case, you need to import your NumPy package. Import NumPy as NP. If you have aliased it, then only you can access that in that manner. Bertrand, you shared one code right now.
Yes, ma'am, excuse me. I've typed the code, and when I run it, the shape of the code gives me one double three, like 133. I don't understand. Why is it giving me, why is the one there for?
Okay, so for this one, just check ARR dot ndim. What does that say? Because it's clearly it's not a two-dimensional array.
Yeah, it's a
Three-dimensional
gives
array.
it gives me a three-dimensional array and a size of 9 elements, and an integer. The type is an integer 64. So
yes,
but this the shape is what doesn't match.
It gives you 133, right?
Yes, ma'am.
Yeah. So it means that it occupies the first position of your three-dimensional array. And in that first position, it has 3 rows. So for that, you have 3. And again, 3 because you have 3 columns, 3 rows and 3 columns. Okay.
So the first position is like the first array in the program.
Yeah, this is the first array in your three-dimensional array that you are creating. First
Okay.
position.
Okay, I understand.
Okay.
Thank you.
All right. So you can experiment it. It is a very good way, a very good approach to learning any programming language, that you should keep on experimenting, just like Bertrand just asked me, by experimenting on his own. So try doing that. It will give you a lot of useful insights, okay, from the programming concepts. Next, we shall move to array indexing. So how can you access the elements defined within your NumPy array? Swapna, what is the error? You can just post it. And are you using Google Colab? You can unmute yourself. It's not really convenient to talk over text. Can unmute yourself?
Yes, ma'am. NP is not defined. It is showing.
Are you using Google Colab?
Yes, ma'am.
NP is not defined. Have you imported it?
Yes, ma'am. Ma'am, I just quoted what you showed.
No. You have to import your NumPy package. Okay.
Okay,
So
ma'am.
only after importing you can use it. So write the statement import NumPy as NP. Only after that you can access.
Check the chat box. Bitreon has given this line statement, import numpy as NP. That line you have to write down the top, I think they will.
Yes. Also, one more thing, that once you import the library, just one cell you need to execute. You don't need to import it again and again in different port cells. If once you have imported, it will be available throughout the entire notebook. Okay. So Swapna, you just add this statement first and then you execute the code, it will run. Okay, so moving on, I'll discuss the array indexing part. So now first you define your NumPy array. So if we want to access this first element, we will write ARR 0. And if now we can access the first element. Suppose we want to access the element present at index number 2. So we have 3. So it is also having 0 indexing. So first element is present at 0 at index number 0, 1, 2, and 3. Okay. So suppose that we have a 2-dimensional array and we want to access some element from this array. Over here, we have 2 rows of this 2-dimensional array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is present in the second row. If we want to access second element on the first row, which means 2, we have to give the location of this element. So for second element on first row, first we have to mention the row number followed by the column number. So this is the way in which you will index your 2-dimensional array. So we have row number, and we have column number. Okay. Now, if you want to index some other element, suppose I want to locate this part. So we will go to the second row, which means 1, and we want to access the element 9. So for that 0, 1, 2, 3. So first, the second row and the numbers. So now we access this element 9. Try to understand how we are indexing the NumPy array. So we are mentioning the row number. Over here we have second row and the element which is present in the fourth column. Okay. So just like we had normal indexing in lists, we also had something called as negative indexing. So negative indexing is also possible in your NumPy arrays in the similar way that we did for lists. So when we want to access the last element, we write -1. So similarly in here as well, if we want to access the last element, suppose we have this array, or 1-dimensional array, and we want to access the last element. Okay, just let this one be. I'll write it in a separate code cell. So we want to access the last element. We will write ARR -1. So this sort of indexing is also available. We can also apply negative indexing to your 2-dimensional arrays. So in that case, suppose we want to access the last element from some particular row. So we specify the row number, but for the last element, for simplicity, we use -1. So we want to access 10 over here. So it lies on the second row. So it looks something like this. It lies on the second row and it is the last element. So for that, we have -1. Okay, so this completes our basic introduction to NumPy. Next, we will study something called as pandas, the pandas library, followed by a few plots that I will show in Matplotlib. So just everyone confirm from your side whether you have been able to follow along and code and execute the NumPy array creation, array indexing. Just keep responding in the chat box. If I have good amount of responses, I'll begin with pandas. Okay, so negative indexing. Okay. So we have elements present in your array, and it actually starts from 0, 1, 2, and 3. So these elements that you have over here within your array, 0, yeah. So this is your index, 0, 1, 2, and 3. And when you want to try negative indexing, your indexing starts with -1. Then we go to -2. Okay. Then we have -3 for your index, this the next index. And lastly, we have -4. So this is the difference between the usual indexing that we follow and the negative indexing facility that is also available. To the one who was asking this question, is it clear now? Did that resolve your query? Okay. So we will now move on to pandas, and you'll see it is a very good library that you can use to process your data, to even clean your data sets. So we will only go through the functionalities of Panda, like the data types that are available within Panda, that is the series and the data frames, which is popularly used for your data science projects. We are not going into a lot of detail as this is a basic Python workshop. So we are keeping things to a minimal level. So similarly, similar to the way you imported your NumPy array. So now we are going to import the pandas, the library pandas. For that, we use the import keyword, import pandas, which is your library. As keyword is used if you want to give an alias. So now I want to define pandas as PD. I want to call the pandas library using PD. I want to make it into a short form. So for that purpose, I'm using it. And there we go. So to all those who were encountering troubles while coding with NumPy, make sure now onwards, just have your import statements at the top of your code. And only after that, start writing the rest of the code, calling those library functions and everything. So has everyone loaded the pandas library?
Yes, ma'am.
Okay. Now we shall see a series object in pandas. A series object is like a column in a table. So suppose we want to have a particular, if we are working with data and we want to have a column which is containing some relevant data. For that purpose, we have a panda series object. So it is like a one-dimensional array and it can hold data of any type. So now we have created a list of data first. So just a random list, okay? And we have a variable myVar where we are going to store the series object. We create the series object using this command pd, that is your pandas library dot series. So using this, this is also a way to create, just like we had np dot array. So now we are going to create a series using this series function. And within the series function, we are going to pass the list of objects that we have over here, the list of integers that we have over here. And then when we print it out, it appears to be something like this. So it is like a column. And you can see we have column numbers as well, 0, 1, 2. Those are the numbers associated to each column that we have over here. Try this out on your own. Try with other different data types as well. So now if I want to have a series of, suppose I want to have a series of fruit names. Apple, papaya, orange. Let me increase one more, kiwi. Or okay, and we store it in fruits, a list called fruits. And I name my series my fruits. Execute it. Now you can see that this is how your pandas series object appears. So here we have all numbers. So just look at this example. So at 0 level, we have apple. Then at 1, we have the papaya. Then followed by that, we have all the different items of the list that we just had. And then we created the series object using the list. It follows the same convention. In NumPy, when we were creating the arrays, we wrote np.array, and then we passed to it a list of objects. And we saw that that particular list of objects is getting converted into the desired data type that we want. So over there, we wanted n-dimensional arrays, NumPy arrays. So we were able to accomplish that declaration using np.array. Over here, we are using pd.series. So just notice the similarity in the convention which is followed across all these libraries. So when you start noticing these similarities, you can even work with libraries that we have not discussed yet, but you can just go to the documentation of the library. And once you see that these are the similar conventions that are used, you can even like learn on your own some new library that you want to work with. Okay. So this was your series object. We can also index to the series object, just like we were indexing your NumPy arrays. So at 0th index, we have apple. Suppose I want index number 3. We have kiwi. So this was your basic series object. So let's try something else. So now we have an empty series as well. So this is also one of the things that you can do. You can create an empty series in pandas, and you can also just a simple array that we had. So just see that what is this empty series over here, and then we have simple that data, the one-dimensional that we had, and we are just creating one another series. Okay. So this is containing your integer data. Next, we are going to now understand what is a data frame. So in series, has everyone understood the series object? If anyone has any query, you can ask. So this is like a checkpoint. We completed one particular data structure that is available. So that was like containing a column of data. But what if we want to have a whole table containing data? Just if you have worked with Excel sheets, or most of you must have seen Excel sheets, in that we have rows and columns of data. Similarly, in Python, if we want to load such data, we can use data frames. So data frame is a two-dimensional data structure. It is present in a tabular manner. It has rows and columns. And using Pandas data frame, you can load such tabular data within the Python environment and you can work on it. For now, we are going to create a data frame using a dictionary. So remember that yesterday we were working with dictionaries, and this is how we declare a dictionary. We have two keys over here. The first key is your fruits, and the second key is the numbers. And the contents of the values or associated with the key fruits is this list containing the names of fruits. And for the key numbers, we have this list 352 associated with numbers. So this is your dictionary. Fine. Next, we are going to pass this dictionary to the data frame. So over here, we pass pd.data to pd.data frame, my data set, and print it out. So now you can see that the keys that we initially used in our dictionary, they become the column names like fruits. And this comprises the first column, the data present in the first column of the data frame. The second key that you have, numbers, it becomes the second column name for your data frame. And the contents associated with numbers, they become the column data 352. So now you have a very small table over here, table-like data structure. This is called as a data frame in Python. So this is used for two-dimensional data. Whereas in series, we had one-dimensional data. So series object, the series data type that we have in Pandas, it is only used to create one, a column-like structure that we have. So someone just asked, why can we use 1D array with series? Only 1D array. So series is actually used to imitate a column in a table. So a column will only contain one-dimensional data, one single data. Okay. So for that purpose only, we have 1D arrays holding the data that we are going to load into the series object. And for two-dimensional data, if you want to have a tabular format, for that purpose, we have your data frames. So just like over here, we declared one data frame. So I hope that answers your query, Roshan. Okay. So whatever data structures that we have declared within the different libraries in Python, everything has a specific purpose. So I am just telling you the purpose for which you may be using to process the data sets, or if you want to work on your own data science project. So how are you going to do that? For that purpose, I'm just telling you the utility. So has everyone defined their own data frame? I'll just copy it to save time for writing. Okay, fine. We can have another data frame. So I've included lots of examples so that you can practice when we share the notebook with you. Another data frame that we can create. Again, we have two keys, calories, duration, and we have a list of values associated with it. And when you pass this to the pd.data frame function, over there, when we are passing this dictionary containing the keys and the values, again, it becomes a particular column name and the values contained within the column
again the next column name, and the values contained within the second column. Now, if you want to index the values contained within your data frame, we use this particular convention for indexing data frame. There are multiple conventions available. So if you want to study on your own, you'll see that there are lots and lots of functions available with which you can index your data frame. For simplicity, for the purpose of simplicity, we are using the df.loc function. So we can refer to the row index. So over here, I want to access the elements present in the first row, the 0th. So for that, I write df.loc and the row index. And when we execute it, we have calories and duration, the values associated with the for each of the row items. So this is how the first indexing that we can do. We can access the elements in an entire row. Now, if we want to access multiple elements, for that, we use this particular convention. We mention the list of elements within LOC. Again, we have a list of elements, the particular rows that we want to access. So now if I want row number 0 and row number 1 over here, I'll mention 0, 1. And when I execute it, I get a section of the table containing the 2 rows. Suppose I wanted the 0th, the first row and the last row. So over here we have only 3 rows. So I'm using the index 0 and 2. And if I execute this, so you can see for yourself that we were able to index into the data frame, and we got the data like 420, 50 and 390, 45. So the first row and the last row, we have been able to access it successfully. Okay. Next, we are also going to see how we can give each row a name. So over here we have, we were able to have column names, but our rows appeared like 0, 1, 2. So you can also name your rows in a way that when we are using the pd.dataframe function to declare a data frame, over there we have the option called as index. So if you write index equals, then the list containing the names of your row, and if you execute that, you get day 1, day 2, day 3. So this is your row names. Fine. It is the same syntax, just one parameter that you add within your data frame function, and over there you can specify the other requirements. So now we can also access the indexes using the row names. So earlier, like we were accessing it using 0 or 2, using the df.loc function property that we have over here. We were indexing using the column, your row significations like 0, 1, 2. Now that we have assigned row names, we can access using the named indexes. So if I want to access day 2, then you can write calories, duration. So this is the data for your day 2. So again, if I want multiple data, I specify day 1, day 2 within a list, another list over here. See, so now just this, you can see a lot of similarity is there in the syntax which is followed. So like 0, 1, we were writing over there. So over here, we are accessing using the row names. Okay. We'll discuss this later on. I'll also give you a brief introduction to Matplotlib if we have time. So anyone, any questions till now?
And they will take one break. Okay, 10 minutes, fine, 10 to 15 minutes.
So shall we
After
have the
that-
break now?
Yes. 10 minutes we'll take the break. After that, we'll start at 11:40 or 45.
Sir,
Okay.
our attendance.
Okay, attendance I'll send, don't worry. Okay, I'm taking here, from here I'm taking. Okay, so don't worry for that. And at 11:45 again, Debolina will continue with this. After that, we have to show one project. And we'll show the list of projects to them. Okay.
We have come up with very unique ideas for all of you. Whichever area that you are interested in, whether it is in web app or web development or in ML, NLP, data science. So we have given you project suggestions. We have prepared a list of projects for you where according to your own interest, you can explore. And we will also provide you with some resources as well. So please attend the next session. It is very important. I'll also show one mini project, how you can work on machine learning. So we will go through an entire mini project together. Okay.
Okay, and I will request, Miss, will request all of you just do one project. If you are not going to do a project, then you cannot learn everything about this Python. Okay, at the time of implementation of the project only, you will know many new things and you will face problem, you will face the error, how to solve that one. So everything will face only after if you are going to do a project. Okay, so I will request all the 46 participants, so go for the project. Okay, then we'll take 15-minute break, Debolina, then again we'll join at 11:45. Fine.
Okay. Yes,
Okay.
sir.
Thank you to all. Bye.
Thank you all.